Forces for GCSE, IGCSE, my Year 10's physics group, and George, my Year 11, who's doing his GCSE physics. Forces. If you have 10 newtons going this way and 10 newtons going in the opposite direction, the two 10 newtons will meet and you get a resultant of 0. Nothing happens when they're equal. If you have 10 newtons going that way and 10 newtons going that way, hold on, then the result is 0. You add them together. And you just decide one direction is plus, one direction is minus, and you see what you get. If I've got 11 newtons against 9 newtons, 11, take away 9, this one's going to win by 2. If my physics students are pushing me backwards and I'm pushing me forwards, because I'm bigger and stronger than them, most of them, maybe not Daniel, I win. I push them back, I'm stronger. Friction always opposes motion. So if something's moving down a slope by slipping, the friction will be up the slope. If the same thing, possibly a book, is being pulled up the slope by a string, the friction is trying to stop it moving. It will be down. Friction happens because atoms and other atoms, their electrons interact, and they don't like atoms moving across them and moving away. Come back. And that's what causes friction. A little bit, about 10%, is because of the crunchy bits of the microscopic shape of the two things that are moving across one another. But most of the friction is due to transient bonds. The electrons being attracted to the neutrons of the other atoms. Friction. So if you have a slope and you have a book on it and it's not moving, it would like to move downhill, of course. But the friction is opposing motion. The static friction is holding it on your slope, your inclined plane. The book is not moving down because the friction force is bigger than the component of the weight. Weight is always directly down towards the centre of the earth. Some of the weight is along the slope, trying to push the book down the slope. And that's when you need trigonometry and a bunch of math to find out how much of your 10 Newton force is going down the hill. And F equals ma. Force equals mass times acceleration. Mass is in kilograms. Force is always in newtons. People's weight should be in newtons. In physics, it's in newtons, okay? If you ask somebody their weight in real life, not in physics lessons, in real life, people will tell you their weight and they'll say how many kilograms there are, how many pounds there are, how many stones, if they're English, they are. But in physics, we have to separate weight and mass because, well, we're sending rockets to the moon. People going, oh, I'm 10 kilograms. Don't, I'm 10 kilograms? I'm 100 kilograms. Don't have to think about sending things to the moon. Physics people do. We train people for NASA. And so, yeah, we send people to the moon. Yeah, we definitely got to the moon. Have you seen CGI from computer games from the 1960s and 70s? Yeah, we definitely got there. We filmed it. It would be very difficult to fake it. And all the strangeness, all the footprints and the lack of wind and the boinging backwards and forwards of the flag. Yeah, because the moon is strange. There's no air up there. You'd expect weird stuff to happen, different from Earth. The dust is very fine and there's no wind up there. So yes, the footprints are still there. Anyway. Yes, it's weird on the moon. Forces. You've got frictional forces, you've got thrust forces from an engine, a jet engine or a car engine. You've got up thrust that helps you lift up your dad when he's in the swimming pool, or a rock if your dad's not there. But as soon as you lift him into the air, then suddenly he has his normal heaviness and oh dear, you can't lift him anymore. But while he's in the water is helping you lift your dad. Because your dad, when he gets into the swimming pool, makes all the water go up. And the water going up, wanting gravity to pull it back down again, that force of the water wanting to go back down to where it was, gives you the up thrust that makes it easier to lift your dad up if he's in water. Up thrust. We've got surface tension, which is a very weak force, but you can get a needle or one of those curly things that hold papers together, paper clip, put it carefully, using another paper clip, onto the top of water, and you can get it to, no, it doesn't float. It's surface tension. It looks like it's floating, but it doesn't float. You push it a little bit, it sinks. Things that float have got less density than water. Gravity pulls the heavy stuff down, and that means the light stuff goes up. That's why hot air balloons go up, and helium balloons go up, because they might be very heavy, but they're also mega big hot air balloons. And so, density, mass divided by volume, the bigness is important. If you're less dense than air, you go up. The dense things are pulled down by gravity. That's why if you drop a nail and a cork and a helium balloon, you let go of them above an aquarium, the nail goes to the bottom because it's denser than 1 gram per centimetre cubed. Mass divided by volume equals density. Grams per centimetre cubed. My favourite one. You can also go kilograms per metre cubed, but I like grams per centimetre cubed, okay, that's me. And we fixed it so that H2O, water, is just 1 pure water, 1 gram per centimetre cubed. Nail goes to the bottom. Iron's got much more density. Whereas it's not the heaviness. The whole aquarium of water weighs more than iron. But if you had this big cuboid made of iron, it would be even heavier than the water. It's density that counts. Small volume, but still got a lot of heaviness. That's your iron nail. The cork, if you've got an old-fashioned bottle of wine, or a piece of wood, a chopstick will do, or a toothpick, any piece of wood, apart from lignum vitae, which does sink. Wood floats because its density, mass divided by volume, is less than 1. The more dense things go down. Helium balloon. Oh yeah, the helium balloon doesn't even hit the water surface, it goes up because it's less dense than air. So it goes up and up and up until it reaches the less dense air, because air is being squashed down due to gravity. The less dense air, maybe 600 meters higher than your head. And then it bobs around and then it becomes pollution, lands in the sea and some dolphin dies because of it. Don't do this stuff. Forces. Any others I forgot? Oh, electromagnetic force. Minus and a minus repel. Minus and plus attract. Magnetic forces. North attracts south. North repels north. South repels south. That's called like forces, like things repel. So north is like another north. And so they repel. Unlike things attract. North and south, they're different. They're the opposites. They attract. Like things, minus an electron, minus another electron, they repel. Minus repels minus, like things repel. Opposite things, unlike, plus, minus. Electrons are much smaller than protons. Plus and minus attract. Electrostatic forces. Any others I remember? Okay, there's going to be some I've forgotten here. Put it in the comments down below. Can't think right now. Lesson ends. Good luck, guys. Oh.